In this demonstration, I will illustrate how to segment tentpole ruffling on a single cell. Tentpole ruffling has been described by several, and there is one particular paper I'd recommend, a recent one from November 2018. Nicholas Condon uses a lattice light sheet to image these structures dynamically. They appear as you can see them here, typically on the surface, but sometimes there are internal structures too that lead to this external structure. So we'll try to identify these using the Pixel Classifier. Start by moving here to 2D, turning on the Pixel Classifier from the Analysis Tools tab. By default, I have two classes. I will need three in this case. The actual tentpole right here. Move to a different Z. Okay, the background and the cell itself. Okay, the preview is already turned on, so you will very briefly see segmentation of this data set. Definitely background here. Okay, so that's looking pretty good already. Let's look around in the different Z position. Let's check here. Seems like we're still getting a little bit. These areas are still being considered to be part of the cell. In fact, they're not. I think that will do the job. There's also some internal structures here that look very similar to the tentpole. So I'll also paint those as well, because I'm interested in getting those included. Okay, I think that is all the training that I will do, and I'll then turn this to segmentation. Turn the region of interest first of all, so we can check it out. So I can turn the region of interest here on. So just this part is going to be previewed in 3D. I can come to 3D, and now we should see this as a 3D mesh coming up, as well as a part of the cell being rendered as a 3D mesh. So we're generating a preview right now. Okay, that's done. And you can see the structure has been detected reasonably well. Once the Pixel Classifier applies to the image, we then have two new object sets, one for the cell and one for the tentpole. And we can see here the tentpole detected where you would expect it. So it's this structure here. So right now I'm showing both the volume rendered data as well. So that's the volume rendered data. We have a 3D object set for the cell, and then another 3D object set for the tentpole. And we can have information for the tentpole, for example. That's this structure here. We know how big it is and its properties. It's also interesting to look from inside, perhaps from the opposite direction. at its contact points with the inside of the cell. And you can see them now. And that is how you would do the segmentation of the tent pole using the Pixel Classifier.